economic order quantity. We call it as EOQ, and it minimizes the annual cost. It deals with the cost of ordering and some certain conditions, and it is also known as economic lot size formula. Let us learn few terms that we use in this topic. R is the demand, the requirement per unit time. R is the requirement, and C1 is the holding cost. C2 is the shortage cost, but we are not using that term here. N is the number of orders per year. I may place 3 orders per year, or I may place 2 orders per year, but here the N is the number of orders per year. C3 is the ordering cost. C3 is the ordering cost. T0 is the time taken to place the orders. So, here T0 is equal to square root of 2C3 divided by C1 R, and EOQ is equal to Q0. We call EOQ as Q0 also. Q0 is equal to R into T0, that is square root of 2C3R divided by C1. That is the formula to calculate economic order quantity. And N0 is the reciprocal of T0. So, N0 is equal to 1 divided by minimum inventory cost per unit time, and it is C0. C0 is equal to square root of 2C1 C3 R, that is C0, minimum inventory cost. Carrying cost is Q0 by 2 into C1, ordering cost is R by Q0 into C3, and at EOQ, at economic order quantity, ordering cost is always equal to carrying cost, and the total optimum cost formula is RP plus square root of 2C1 C3 R. First problem in exercise 6.3. The following table gives the annual demand and unit price of 3 items. For 3 items, it is given A, B and C. So, for each item, annual demand and unit price is given. So, ordering cost is ₹5 per order, and annual holding cost is 10% of unit price. Unit price is 10%. Determine the following: EOQ in units, minimum inventory cost, EOQ in rupees, EOQ in years of supply, number of orders per year. So, for the first product we are going to find it now. Annual demand is 800 and ordering cost is ₹5. Ordering cost is C3 and it is ₹5. Holding cost is C1. C1 is 10% of unit price. What is the unit price of product A? It is 0.02. So, 10% of 0.02, that is 10 by 100, that is 10% into 0.02. You can use calculator to do all the calculations, and it is 0.002. First thing, so now we have R, C1 and C3. So, we can find EOQ, economic order quantity, that is square root of 2C3R divided by C1, that is square root of 2 into C3 is 5 into R is requirement, demand 800 divided by C1, that I get square root of 40 lakhs, that is 2000 units, and it is Q0. We used to denote EOQ as Q0. Minimum average cost. Minimum average cost is square root of 2C1 C3R, square root of 2 into C1 0.002 into C3 is 5, R is 800 and its value is 4. Next, EOQ in rupees. EOQ in rupees is equal to EOQ in units into unit price. EOQ in units is 2000. Unit price is 0.02, so that is equal to rupees 40. Next, EOQ in years of supply, that is T naught. T naught is equal to Q naught divided by R. Q naught is EOQ. EOQ, that is 2000 divided by 800, that is equal to 2.5. Number of orders per year, that is N naught. So, N naught is equal to R by Q naught, the reciprocal of T naught. So, you can find it directly here, or 800 divided by 2000, that is equal to 0.4. Second problem, a dealer has to supply his customer with 400 units of a product per every week. The dealer gets the product from the manufacturer at a cost of rupees 50 per unit. The cost of ordering from the manufacturers in rupees 75 per order. The cost of holding inventory is 7.5% per year of the product cost. Find EOQ and total optimum cost. Requirement R is equal to 400 into 52. 400 is the required units per every week. For a week they need 400. So, for year we need to multiply that value by 52 because every year has 52 weeks. Okay. So, adnala 52 ala multiply pandrom, that is equal to 20,800. C1. C1 is 7.5% of unit cost. So, it is 7.5 divided by 100 into 50, that is equal to 3.75. That is also for a year. This value only for a week, but this is the cost is for a year. C3 is rupees 75 per order. So, first we have to find EOQ. EOQ is equal to 2RC3 divided by C1, square root of 2RC3 divided by C1, that is square root of 2 into R is 20,800 into C3 is 75 divided by 3.75, that is square root of 8,32,000, that is equal to 912 units. Next, a second subdivision, total optimum cost we have to find. Total optimum cost is purchasing cost plus minimum average cost. Average cost. So, purchasing cost is for 1 unit it costs rupees 50. So, for 400 units, that is 400 into 50 is the purchasing cost. Minimum average cost formula is 2R square root of 2R C1 C3. Now, let us substitute 400 into 50 is 20,000 plus square root of 2 into R is 400. C1 is 0.072 into 75. 0.072, how did you get this? The C1 is 3.75 per year. So, here we are calculating it for a week. So, we need to divide 3.75 divided by 52. It is for per week. So, while dividing 3.75 divided by 52, you will get 0.072, or else here you can write it as 3.75 divided by 52. Okay. So, for a year we are for a week we are calculating. So, it is 3.75 divided by 52 into 75. While doing the simplification, I get it as 65.75. That is, while adding it with 20,000, I get 20,065.75. Okay. So, inga C1 per year ku nama calculate pannirkom, that is what we are using it, okay, here. But here to find the total optimum cost, we need to divide it with 52. Okay.